Alright, hello again, this is Jeff Scott, and I'll be talking to you right now about threat modeling principles, which is one of the last 100 level security development lifecycle SDL field content lectures that we'll be going over. So, in here, as it says, we're going to have an overview of the Microsoft SDL threat modeling process, talk about when you should threat model, who performs threat modeling, what to threat model, and discussing the threat modeling process, tool, and requirements. Now, the stuff that's in that'll be presented here, some of it at least, is a little outdated because Microsoft did just come up with the Microsoft Threat Modeling Tool 2016. All right, I've done these PowerPoints before that though. So as we go in and we start talking about an overview of threat modeling, again, the threat modeling process is used to identify security threats to a system and also establish appropriate mitigations. When threat modeling is performed correctly, it enables the application development teams to deliver safer and more trustworthy applications. These applications will have higher efficiency and confidence, all right, because the known classes of security vulnerabilities are understood and have been effectively addressed. Any application developed using the Microsoft Security Development Lifecycle must have threat models completed for all at-risk features and functionality. Threat modeling then is a very key component of the Microsoft Security Development Lifecycle. You can kind of break this down, as it mentions right here, into 4 different steps. Diagramming, threat enumeration, mitigation, and validation. All right? Well, let's take a look at it right here like this. During the first step here, diagramming, the application that's being threat modeled is expressed as a data flow diagram, or DFD. A data flow diagram shows the data flowing through an application. So in other words, it's something that most developers like to use because it's very real and it's more reminiscent of the way data actually flows through a system. All right, next, during the threat enumeration stage, threats to the model systems are identified. After these threats have been identified, mitigations to the threats are selected, all right, and that's the mitigation step. Then finally, during the validation step, threat models are validated to make sure that they're both complete and accurate. All right. Now, one of the major benefits of the Microsoft SDL threat modeling process over other threat modeling processes is that it can be performed both by security experts and non-security experts. Now, I don't want to get too off on a tangent here, but I do want to show you that the threat modeling tool looks like this. All right, doesn't look like really a whole heck of a lot right now, but I want to show you this anyway. What happens is if you come in here and you can create a brand new model, or you can open an existing model. I think I've got an existing one right here. Okay, it's not found because I'm in the wrong directory. But if I want to, I can come in and create a new model. Okay, this is the drawing surface right here, and these are your different tools over here. So if I want to create an OS process, I can click, hold down, drag it over, and boom, there it is. All right, I can go in and add whatever it is I want to add then. And as I do this stuff, and as I add more things, so if I come through here and I add a native application, for example, and I add a browser client, and then I come in and I start saying, well, you know, I'm going to have to somehow start connecting these things, and I start to connect the stuff that's in there. All right, what's going to happen is the system, as it goes through, is it's going to say, oh, well, you've got things that are missing here. All right, So it'll go through, and again, I don't want to get into it in any depth and breadth of coverage right now because we're going to have a whole lab on this. All right, but I'm just trying to show you this is the tool. When you get done with the tool, there's different things that you can do based off of the tool. All right, in other words, there are reports that you can create. So I can come in here and create a full report. Now, right now, you know, there's not going to be anything that's really going to be in here. I'll just throw it on the desktop. I don't even know if it's going to create anything. All right, so what does it say? It says this is what I have, and here's the diagram summary. Now, that's not really anything, but the point is, all I had to do was drag some stuff out there, so it's very reminiscent, this drawing surface that you have under the Threat Modeling Tool 2016. It's very reminiscent of creating a data flow diagram. Okay? I'll just leave it at that right now. So, as previously mentioned, one of the advantages of doing this is that it can be performed by both security people and non-security people. All right, this is especially beneficial in scenarios where in-house security expertise might not be available, and possibly even hiring outside expertise might not be feasible. What you can do, though, is you can get people who are in the know, or as much in the know as possible, together. You draw a very high-level data flow diagram of the system, and then you start drawing more detailed levels. All right. There are a lot of other threat modeling processes also that exist. The process that's described in this chapter and in the threat modeling tool is basically, it's the one used internally at Microsoft. All right. They're not actually claiming that it's the best in the world to use. What they're saying is it's one that Microsoft has agreed upon and works for them. All right, so let's look at an illustration of threat modeling. So what does threat modeling an application using the threat modeling process look like? Well, first, you come in here and an application begins. There's a design that addresses a problem or fulfills some kind of business scenario. Users may end up entering data into the application, and the data may be processed by the application in some way. With the Microsoft SDL Threat Modeling process, these app designs are expressed or modeled as a set of DFDs, as shown right there. These DFDs provide a standard graphical representation of data as it flows through the system. Then in the next step, what we do is we identify the threats to the application, and Microsoft uses their STRIDE method. Remember, STRIDE is an acronym for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. After the threats have been identified, mitigations are selected for each of the threats. All right, and they're showing one right here. Now, you know, the question often gets asked, when should you threat model? All right, and the idea is several times during the process. Really, when you threat model during the design phase, it probably has the greatest value because you'll find errors, and the more errors you find, and especially the earlier in the process you find errors, the less it will cost to fix those errors. So it's kind of an important concept right here. All right? Microsoft's experience has said that it's much easier to modify an application design than it is to work backwards after something's already been implemented. It's easier and it's less costly. All right. So who performs threat modeling? Threat modeling is best performed, as mentioned, during the design phase. At this phase, the greatest flexibility to make changes occurs because typically little to no code has yet been written. So the next question might be, who in the application development team is going to be responsible for performing threat modeling. Should they be security experts, non-security experts? Okay. And, the smart aleck answer is yes. I mean, security experts will be able to threat model an app faster and more effectively than non-security experts. All right. But it might not be realistic to assume that security expertise will always be available in the application development environment. All right. So in response to this, the Microsoft SDL threat modeling process was designed so it can be performed as mentioned by both security experts and non-security experts. Anyone within an application team that's familiar with the design of the application can conceivably use the Microsoft SDL threat modeling process to conduct necessarily threat modeling activities. Threat models should be updated and reviewed whenever a change to the application's functionality and feature set is made. Now, at a minimum, all right, what that says is when you add new features or modify existing features. But what you quite often find happening is, again, you'll threat model during the design process. All right, you might threat model again after the initial code review. You'll probably threat model again at a minimum, right before the process is going, or before the application is going to be released to the customer. So at a minimum, you're probably going to have 3 different stages of threat modeling. There may be more, there may be less. And it's important that when you first start doing this, when you first begin the threat modeling process, and you get in your meeting for maybe the first time, what you're trying to do there is you're just trying to identify the threats. You're not necessarily trying to figure out how to mitigate them, because there's time to do that later. So what to threat model? So far we've established when to perform threat models and who should be performing it. So the final question that kind of needs to be answered is, what should be threat modeled? The application as a whole should be threat modeled, since the potential for attack is present throughout the entire application. Individual threat models can be created for certain components. However, the overall threat modeling process, at least when you start, should be for the entire application. In addition, security and privacy features in particular should be threat modeled. Why? Because these are the controls present in an application that help reduce the risk of attack. Things like authentication and authorization. But really, any application feature whose failure has security and or privacy implications should be threat modeled. And then finally, any application features that cross trust boundaries should be threat modeled. We'll discuss trust boundaries in just a minute, but just to kind of give you a heads up, trust boundaries are points within an application where data flows from one privilege level to another. All right, so what are the advantages and disadvantages of Microsoft SDL threat modeling? Okay. The first advantage, as you can see right here, is that the process can be used to find threats in an application design early in the software development lifecycle. We've already mentioned that the earlier you find them in the process, the less costly it's going to be to fix them. Okay. And again, that's one of those things that ideally, at least, just makes sense when you hear it. Another advantage is that it can be used both by security and non-security experts. As we've already mentioned, you have no guarantee that you're going to have a multiple number of security experts, and with those security experts, are they going to have the time to put the effort in that needs, maybe on a regular basis involved in threat modeling. Next, threat models provide insight into the anticipated threats to an application design for application development teams. Designers can use this and design apps that address these types of threats. Developers can take it and they can already try to bake in security from the get-go. Security testers benefit from threat models. They can focus their efforts on areas of the application that have the highest potential for attack rather than those with a lower potential. But as you'd guess, there'd be disadvantages too. The key disadvantage is the cost. All right, because again, there are upfront costs with this. All right, you may have to train people. You may have to buy, you probably will have to buy additional software. There's setup costs. So it's not necessarily cheap, and it's not necessarily cheap both from a person perspective and from a cost perspective. Okay? All right, so let's go through and take a look at the process. Every application, and you've seen this stuff before, begins with a vision. All right? In other words, there's a set of business objectives that an app is trying to address. Security features might be added, but you're going to come up with scenarios and figure out what it is and use cases, etc. From there, when the application design becomes available, the threat modeling process begins. In the first step, application designs are modeled or expressed as data flow diagrams, or DFDs. Again, a DFD is a hierarchical, typically graphical type of representation, I should say, of the flow of data within the system. Next, these threats are going to be enumerated by analyzing the DFDs. Third, you want to go through and you want to mitigate. All right, in other words, you want to come up with ways to solve those problems that you have. And then finally, you have to validate what you've done for completeness and correctness. Again, we talked about this before. Whenever the app's design or code implementation is changed, the threat modeling process has to begin again to reflect the new states and to identify any new threats that have possibly emerged from the changes that you've made. So let's take a look at these steps in a little bit more depth and breadth of coverage. We talked before, way back, diagramming, threat enumeration, all right, mitigation, and validation. So let's take a look at those in some depth and breadth of coverage. So first is diagramming. And as it says here, the objective of this step is to take an application design and basically model it as a data flow diagram. And there's several reasons that threat modeling uses data flow diagrams. The first, it's a fairly standard way to graphically represent data as it flows throughout an application. It's widely used and it's easily understood. And one of the reasons for that is there are only about 5 or 6 symbols that are used in data flow diagrams. What this does is it enables the Microsoft SDL Threat Modeling process to be used by a broader set of application development teams. Not just those from Microsoft, but since you're using standard tools, anyone basically can use it. The other reason for using data flow diagrams is that most application attacks are based on data flowing through a system. DFDs thus provide a natural way to model these kinds of attacks. All right. In addition to the standard data flow diagram element set, all right, the Microsoft SDL Threat Modeling introduces the notion of trust boundaries, which are used to represent data as it flows from one privilege level to the other. And you're going to see this in a bit. So, I'm not sure why that looks so funky on here, but let's see if I can pretty this up just a bit. Looks a little bit better here. All right. So here are your major symbols that you have in a data flow diagram. All right. The first is an external entity. This is drawn as a rectangular box, and it represents aspects not within the control of the application. For example, could represent users, could represent websites used by the application, could represent other systems. The next element you see there is the process element, and that represents an application or code within an application. Sometimes this is shown too as kind of a rounded rectangle. All right, so you'll see that it is in both ways, not as a rectangle here, but more a rounded one. All right, it's kind of turned, this one turned on its top, but more rounded with a little bar across the top of it. The third element, DFD element, is the data store element. Notice that the data store represents data at rest. And typically it's equated with registry keys, but even more so than that with databases. The fourth element is the data flow element, and that's an arrow. It doesn't have to be curved like this. All right, but the idea is it describes how data flows from element to element. All right. Now we mentioned trust boundaries before, and this is an additional, so these are basically the four elements that are used for DFDs, kind of in a standard way, but Microsoft has added another element here. It's a dotted line that's used for trust boundaries. So again, these are not part of standard DFDs, but they're part of Microsoft's DFDs. And as mentioned previously, a trust boundary is a point within an application where data flows from one privilege level to another. It could be something like network sockets, external entities, processes, etc., but something within there that has different trust levels. It's crucial to document these trust boundaries because they indicate areas where threats can potentially manifest and often indicate areas within an app that must be analyzed in more depth and breadth of coverage. So, we looked at step 1, which was diagramming, on to step 2, which is threat enumeration. Here again, you want to identify threats for each data flow diagram element in the threat model. Now, security experts can complete this step through brainstorming sessions and employing other informal methods. But the problem with brainstorming is, first of all, it's hard to do. It really and truly is. And what I mean by that is you can bring a group of experts in together, but when you truly brainstorm, the idea is nothing is too wild and crazy, so to speak, that anything that anyone comes up with can be considered. So if somebody throws something out there, you're not allowed to comment and say, well, that's crazy or whatever. Good brainstorming can take a lot of time. It's not typically something that you're going to sit down and in 2 or 3 hours you're going to brainstorm and figure out everything you want. In fact, the longer a particular brainstorming session goes, sometimes the less that will get done. Because people will start worrying about the other problems and get off on their own little tangents, etc. All right? So an alternative to brainstorming is to use the stride method, which we've talked about before. It can be used by both security experts and non-experts. First, you document the desired security properties that the app must have. Then you document the threats that could compromise those desired properties. Then you come through and you bring in the stride methodology. And as mentioned, stride stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. There they are. So think about these. Number 1, spoofing. All right, impersonating someone or something else. Well, what would be the opposite of spoofing? And that would be a natural type of authentication, a true authentication, a right authentication that works. Second is tampering, modifying code without authorization. Well, how do you get around that? Typically, the way that you get around that is through things like principle of least privilege. Third is repudiation. All right? So how do you get around repudiation? Well, as it says there, it's non-repudiation. So you come up, typically it's things like log files that you use, so that if somebody claims they did something, or I'm sorry, if you claim that somebody did something and they claim they didn't do it, all right, if you've got a log file, quite often you can prove that they did or didn't. Then you've got information disclosure. Well, typically, as mentioned there, that's confidentiality, and you don't want that. All right, you want confidentiality. You don't want the information disclosure because you don't want to expose your information to unauthorized users. Fifth is denial of service, where you don't want that, you want availability. Finally, elevation of privilege. Okay, but you want authorization, but the person should be authorized to do whatever it is they're supposed to be doing and nothing else. The Microsoft threat modeling process, as mentioned previously, is used by both non-security experts to enumerate potential threats to an application, and it can be used by security experts for pretty much the same thing. The chart that you see right here shows common stride types by data flow diagram elements and can be used as a baseline for enumerating threats. All right, so as they say there, to use the chart, each DFD must be analyzed for appropriate threats. For instance, if the data flow diagram of the model app contains an external entity element, then the threats of spoofing and repudiation must be considered. Alternatively, if the data flow diagram of the model app contains a process element, then all stride threats must be considered. You might notice that when we go down to data store down here that there's a red check mark. This color coding is used to indicate that the data sources are sometimes affected by repudiation threats. Sometimes. Data stores are affected by repudiation threats whenever the data stores themselves, the data stores themselves are a log. All right, the third step that we want to talk about is mitigation. So after the threats have been enumerated, the next step is to select mitigation to address those threats. The 4 ways to address the threats in the Microsoft SDL Threat Modeling process include: first is redesign. So you redesign the app to eliminate identified threats. Typically this is the preferred mitigation path, but there may be situations where an app cannot be further redesigned without removing vital or valid business functionality. Next, you could use standard mitigations. These types of mitigations are well understood. They're the preferred mitigation path if redesign is not necessary. Examples are using access control lists or ACLs to protect registry keys, using SSL to protect network connections, and using the principle of least privilege to isolate elevation of privilege attacks. If standard mitigations can't be applied, then the use of unique or customs may be more appropriate. A unique mitigation is often difficult, time-consuming, and may be risky to implement. Implementing a unique mitigation properly requires deep expertise in the particular technology the mitigation is being developed for. For example, database and network protocols. Finally, the last approach to mitigating threats is just to accept the risk in accordance with policies. Sometimes redesigning an app using standard mitigations or using a unique mitigation might not be practical. For instance, it may be less expensive to accept an application risk than it is to redesign it or implement a standard mitigation. Or there may be certain assumptions or external dependencies that an app makes that mitigate certain threats that may need to be communicated to users. Some examples of standard mitigation, and these aren't that easy to read, I understand that. But again, spoofing, IPsec, digital signatures, MACs or message authorization codes, hashes, tampering, ACLs, access control lists, digital signatures or again MACs, repudiation, strong authentication, secure logging and auditing, information disclosure, encryption and ACLs, denial of service, ACLs, quotas and high availability designs, and elevation of privilege, ACLs, group or role membership, and input validation. All right, if you go to the Microsoft SDL and look at Chapter 9, there's a big section on that in there. All right, so step 4, our final step of our 4-step process, is validation. The objective of this step is to help ensure that threat models accurately reflect application design and potential threats. Models should be validated to ensure that they completely and accurately and sufficiently reflect the actual application design. Because if they don't, inaccuracies or insufficiencies could result. Some guidelines to model. All right, you want to make sure that your data flow diagram contains at least one trust boundary. You want to ensure that all data flow paths are properly represented. You want to ensure that all data sources are represented in the model. Enumerated threats have to also be validated for completeness. Mitigation should be labeled clearly if there to be a standard mitigation or a unique mitigation. They should also have some kind of a tracking item open in a tracking database, at a minimum with something like a number and a description, title and a description, something like that. Finally, any assumptions or dependencies that are noted during the threat modeling process should have at least one corresponding test case to validate that assumption. We already mentioned the threat modeling tool, and again, this is the older copy of it. So, some threat modeling requirements. Let me back up, there we go. We've seen throughout this presentation that threat modeling can help application development teams develop safer and more trustworthy apps. Apps that have been properly threat modeled are likely to be more resilient to malicious user attacks. And since the inception of the Microsoft SDL in 2004, Microsoft has required that all product teams create threat models, and that all threat models meet the following requirements. The first requirement is that all functionality defined during the cost analysis phase, which is called stage 2, must have corresponding threat models. All right. Second, all threat models must meet minimal quality requirements. They must contain DFDs, assets represented by the DFD elements, enumerated threats, and mitigation. Next, all threat models and reference mitigations must be reviewed and approved by at least one developer, one tester, and one program manager. Finally, threat models and any associated documentation must be stored using document control systems. In other words, there must be a way to permanently record this information. So, in conclusion, We talked about the threat modeling process and how the process enables application development teams to identify security threats to a system, determine risks, and establish appropriate mitigations. Remember, the Microsoft SDL Threat Modeling process yields the greatest benefits to application development teams when it's performed as early as possible in the software development lifecycle, or SDLC. Specifically, the design phase is an ideal point. At this stage, any changes to the app can be done easily and with a lower cost as compared to performing changes later in the SDLC. Additional benefits include the ability to use the results from threat models as a guide to focus security verification efforts. The Microsoft SDL threat modeling process, as we saw, consists of 4 steps. The first step is diagramming, where application designs are modeled using DFDs. The next step was enumerating threats against the DFDs. Here, the threat modeling process uses the stride model and maps different stride threat types back to specific DFD elements. After the threats have been identified, responses to the threats are chosen. The 4 basic approaches, we looked at those. 1 was to redesign to eliminate the threat. 2 was to use standard mitigations. 3 was to use custom mitigations. And 4 was to accept the threat according to company policies. All right, and finally the last step was to come in and validate the threat models to better ensure that they're complete and comprehensive. Again, to do this, Microsoft has come up with this threat modeling tool to try to make it easier for people to use. Threat modeling, as mentioned previously, is a required activity within the Microsoft security development lifecycle. You've already seen the picture, and I've talked about the book already. Here's the official SDL website. We've looked at these already. I mentioned I have this book, and Doug will get it from me as soon as we're done with the presentations. And Microsoft has a Security Developer Center at MSDN, which is Microsoft Developer Network.microsoft.com/security. All right. Here's their SDL blog. Here's their blog from Michael Howard, who is one of the authors of Writing Secure Code. And here is another book from Microsoft. It's called Hunting Security Bugs. These are things here that we're going to discuss in future lectures. We've already discussed secure design principles, secure implementation principles, and secure verification principles. We've now gone through threat modeling, and in the future, we're going to cover SQL injection vulnerabilities, cross-site scripting vulnerabilities, buffer overflow vulnerabilities. And that's it.